First of all, hi everybody. I am very grateful and privileged that I can share my views for this virtual program conducted by Planotech Media House and Virtual Summit 2020. Myself, Aruna Banerjee. I have been as an AutoCAD draftsman for the past almost 13 years in different companies during this span of time. I have gained good considerable knowledge as an AutoCAD draftsman, and also I work in the sector of water and wastewater. So first of all, the advantages of CAD is enormous in our field. First of all, there is increase of productivity. For the advantage of CAD is increase of productivity, higher quality design, reuse and easily change design, easier to read, simplified and sharing, documenting the design, skill of the designer, etc. So for the advantage and disadvantage of computer-aided design, it is very harsh in our society that the technology is ruling everywhere. For last 3 to 4 months, precisely you have to say that last 6 months, the technology has played a great deal. During the lockdown, every employee in our company and the different company also work from home. So the technology is much more superior in this juncture that they work from home easily and achieve the target easily while they are working at home. So CAD is a very fundamental thing in our society, in our engineering field. So the advantage of CAD is it saves times. When you are using computer-aided design software, basically CAD, it will save your time. You can make a better and more efficient design in shorter time durations. Second point is easy to edit. Whenever you can change your drawing, you can change your name, you can change to modify your drawing. It is quite easy. When you are making design, you may find the need to make the alteration. When you are using CAD software, it will be easier to make any changes because you can fix the error and modify the drawing easily. Decrease in error percentage. As a CAD software, it will minimize your error, which will make sometimes very much problem in our field. So as a CAD software makes use of some base tools, the percentage of error that occurred because of manual designing is significantly reduced. So the best part is in this software is decrease the design effort. You can imagine when our beloved designer, they build and design the same things which we will produce now. It will take longer time to achieve the targeted amount or achieve the targeted design. But nowadays it will be very much easier. As a draftsman, it will pleasure that we have the tool of CAD. So it is a very much win-win situation for employee and employer, and it will very much important in our field. Easy to share. You can share your CAD file in possible manner to in CAD format or PDF to your employer, to contractor, everybody can see your work, and this work can be generated by strong people. They can view their recommendations or suggestion in this drawing. So it will be very much in place, in system. You can put any drawing, and they are simultaneously contractor have a point, consultant have a point, client have a point. So you can accumulate that and put a fresh drawing or modify the drawing easily with quicker. As a designer, this is a very pleasure thing we have. And improve the accuracy. The accuracy is tremendous. There is no error. There is no error at the time of design. Yes, obviously, whenever you make a design for the contractor, as a consultant, you have to put out some great effort. After that, whenever in EPC mode, the contractor will provide the design on drawing, there is some changes. It will happen in every world, every nook and corner. So it is not bothering, but the maximum alteration is very minimal, and it is happening everywhere. So there is no room for concern actually. Computer-aided design CAD involves multiple modify, analyze, optimize the model object part. It will be unite extensively industrial manufacturing environment. It will fit for your purpose actually, and you can view the 3D models there. You can view the 2D models there. You can check and quickly modify your design accordingly. So it will very much win-win situation for every CAD operators and every design engineers. The blessed with this software. So not only the AutoCAD, there is some more software we have in our field. So there is Revit, there is WaterGems. WaterGems is very much in progressions. As my views as a industry, I have working 13 plus years in wastewater and water. So I've seen the ups and lows of everything, and the way the WaterGems is now capturing the market is enormous. That is a key point we have seen before. It is a very much killer performance as per the WaterGems concern. WaterGems, RiverGems. So in distribution network design, WaterGems is unparalleled. There is some software is such like Epanet is there, so you can rely on that. But the accuracy and the pinpoint accuracy provided by the WaterGems is enormous. So this software is very costly. Obviously, if you manage to do accurate and on-time production, you have to invest some money in software also. So that is a killer point. Actually, in my brief experience, I saw the software is running the industry the way. but also you have to choose between the software and the intellect of human. You have to choose this, because the software cannot do the work independently. You have to put the data which the software is needed. So the human intelligence is also quotient is also there, and apparently the software accuracy also there. So this is the win-win situation for everyone, especially the younger generation who are now learning the all tricks of the software. They are most welcome, and this software can be a game changer for their lives. I saw in every department, every sector, that this software learning experience gathers the younger generation a good healthy career graph. So they are now in metro sector. There are so many software in water, so many software in transportation and bridges. There is no software. So the stimulation and the simulation is there. So the software advantages are there, but you have to choose the software for the purpose. Actually, it will horses for the courses. Actually, so you have to figure out which software is your game changer for this project, and accordingly you have to bring all the inputs, all the investment to the software, and learn the employee accordingly. So basically software is there, but the experienced employee are not there. That is the lacking point of our power industry. We should cultivate and we should motivate the younger generation and the present employee to learn the skill of the software. It will be helpful for everyone, for their career growth also, and for the company also. I will urge in this platform that the industry should take this necessary step to literate the people who are working for them with different software. We cannot know whenever this software we will need, but according to need we have to do some work in software. The software is this type of software is very much globally exposed. Actually, in our field, client also approach to design the work with or without software. They have no choice. But I urge the client also. They whenever they going for the DPO or the bids, they have to choose the software which will helpful for them in this project, in that particular project. So that is the main thing, and you have to do it very fast way. In this generation, you have to put your right thing and right place and with the right mind and right people also to work accordingly. So we can deliver the project as a project in stipulated time. Also, there is some negligence in some part of the field that is happening everywhere. So if we do the software part as a mandatory for client, consultant and contractor, that will be beautiful, and both three have to use the same software. That is the important. Sometimes we find that the client have no software which consultant is designed, or Contractor are different software which client and client and consultant has not. So that will be reduced. That will be in a path that both the parties are in same pitch, so there is no confusion at all. And also in COVID situation, there is some lackluster times we have gone through. There is actually the industry's main pillar is the labor. So labor are missing. They are going to their home village for this situation. So we have to wait for that. That is fine, but we have to do some special works. I urge the government to more emphasis on infrastructure project, invest the money in infrastructure project. Already the government is very few state government is back out for their infrastructure project due to COVID situation, but it will not help at all for this juncture. You have to invest the money in infrastructure project, otherwise this cycle is not supervised or not improvised at all in this juncture. Thank you for listening me. It has been great pleasure to as a speaker to speak in this virtual platform. Thanks everybody. Thank you all, and special mention to Planotech Media House for their beautiful virtual summit 2020. I wish them very, very successful summit. Thank you.
Hello, welcome to this domain design and simulation of Virtual Summit 2020. I am Amya Nijasure, research scholar from Pillai College of Engineering. I will be sharing some of my experience related to design and simulation with you all. Working as CAD instructor for last almost 7 to 8 years, I have come across some factors which will affect your selection of designing and simulation software. Okay, so I will be answering some basic questions from where we can start about this design and simulation. Okay, so when we talk about designing of any component or a new product, the word which come in our mind is computer aided design, that is CAD. And we have plenty of softwares which are available in the market which uses the CAD. Okay, so broadly those CAD softwares are divided into two types, that is 2D CAD and 3D CAD. So 2D is called drafting and 3D is called designing. Okay, why I am mentioning this, because it is a general trend that whenever you go for a 3D CAD modeling, you tend to neglect 2D part. Okay, 2D drafting is equally important. The concepts and the basics of 2D draftings are equally important whenever you try to manufacture a product. Okay, so how to draft a model, how to make different views, how to make layouts. Okay, how to make isometric drawings in piping, how to make 2D drawings in piping, drafting. So those things are equally important compared to 3D. So if you are learning any 2D software, try to learn it at least to the basic skill set. Okay, and then you can move to the 3D CAD modeling. There is always the option of drafting in 3D CAD. Try to learn that domain also in 3D modeling. Now, the first question which comes in our mind about CAD whenever you are starting a new software, that is a selection of software. There are n number of softwares which are available. So I will try to divide it into two different types. If you are a student of the university, of a college, okay, so if you are starting with a new software, you always go with the syllabus, whichever software or tool the college or university is teaching, you tend to select that tool. So you can start with that tool, you can get some basic commands of that tool, and then you can move to the whichever software you want. And if you're a professional, you can select software based on various factors. Okay, so this software selection is basically based on in which domain you are interested in. Okay, so for example, let us say automotive industry, and automotive industry uses assembly modeling. So assembly modeling of say Creo and SolidWorks is quite good. So you can search for the industries which are using SolidWorks, search for the industries which are using Creo, and then you can decide which software you want to select. Similarly, for automobiles, you can talk about the surfacing. Surfacing is very widely used in automobile. The NXCAD and CATIA gives the good options for surfacing. So you can just go through the industry around your area, wherever you live or wherever your location is, you are targeting a specific location, and you can check which software they are using, and then you can try to learn those softwares. Okay, it is better to start with a one software, get all the basics of those softwares, and then move to the second software. If you try to learn two softwares at a time, you may jumble up in different commands. Okay, so that is my second point, that is learning basics, how to start learning a software. The best way I can tell you to learn a software is starting with the first command, and you can go for the all the sub options which are available in the first command. For example, let us say we are learning AutoCAD and we are going into a circle command. Now there are 10 to 13 options which are available in circle command for AutoCAD 2D. So you can try all the options, you can refer all the online contents which are available, you can refer a lot of PDFs, books which are available on those softwares, and you can try out all the sub commands which are available in the original command. And that is how we basically start learning the application of each sub command. Okay. Similarly, let us say for SolidWorks, if you are having a command extrude, there are various options which are available in extrude, 13 to 15 options which are available in extrude. So try to understand the role of each option which is provided by the Dassault or a company which is manufacturing that software. So then the important thing is the concept remains same. If I give you an example, if I want to make a cube, how we will make a cube? We will always start with a square at the base and we give height. So this concept remains same in all the softwares which we deal in CAD. Okay, so some softwares will call it pad, some softwares will call it extrude, some softwares will call it maybe a pocket. Okay, so those things will change, but the basic concept remains same, so stick to that basic concept. Okay, and unless and until you have tried any of the product, designing any of the product in that software, never say it is not possible for that CAD modeling. Okay, always if you get any challenging part, try to design it in specific skill which you have, and then comment on that, yes, this software is little bit slow for that part, this software gives a better commands to design that part, and all those things. Okay, so if you get any challenging part, always try that part to make it in the software which you have learned. Okay, and then only say that it is not possible or it is taking more time for this specific software. Okay, uh, now after learning, what should we do for this skill of CAD? So you can do various projects. If you are a student, you can do various projects, you can get into the competitions which are available at many places, design competitions, and you can polish your skills of the CAD modeling. If you're a professional, you can keep on practicing for different projects. You can make a portfolio of that project, publish it on your websites or your professional sites like LinkedIn, GrabCAD. A lot of professional websites are there to show your talent of designing. Okay, so those things you can add on those websites, and you can provide those links on your resume. So that is a good option for projecting what skills you have in CAD. The last option is basically the optional part, which is a certification. If you are a student and if you are entering into the industry for the first time, it's better to have a certification, some kind of certification regard for that specific skill or software. Okay, so certification basically costs a lot if it's a value certification. So always go for the value and the content for which you are going for a certification. Okay, so even though if it is not possible to do a certification, you can always rely on projects and practice. um, that will give you definitely a confidence on that software. For certification, I would like to suggest the many companies like Autodesk, SolidWorks, Dassault, Creo, PTC, all are providing their professional certification, which are most of them are online exams. So you can enroll for that exam, you can learn the basic skills of those software and get past those exams, which are basically international certification or global certifications you can call, and you can get that certification which will add value to your resume. Okay, so this certification is optional, but only point we have to remember for certification is what value it is adding to your profile, and what kind of content are getting covered or delivered in that certification course. Okay, so this is about the computer aided design or CAD design softwares, which are the factors I feel which are very helpful for you people to understand. Just go through these points and try to select the perfect software which you want to select for learning a new skill. Okay, in the next part we will be discussing the basics about the simulation software. Okay, let us move to our next topic, that is the simulation part. And for simulation, when we talk about simulation, the first point comes in our mind is CAE, that is computer aided engineering. And simulation techniques are used to find the various results related to stress, strain, temperature change, okay, safety factor. Those all things can be done through the simulation. Ideally, simulation gives you the approximate value, so you cannot 100% rely on the simulation. But nowadays, the development of softwares is such that those acceptance is getting more and more, and people have started depending on simulations results, and then at at the last stage of your product development, they basically go for the actual prototype and final testing. Okay, so that is the level of simulation nowadays. So for understanding a simulation, it's in very simple words, simulation gives you the answers, simulation softwares give you the answer. So unless and until you feel feed your correct data in your software, you will not get the right output. Okay, so whatever we are inputting into the simulation software is very important. If you input wrong values, you will get wrong output, system will not give any error most of the time. So we call it as garbage in and garbage out. Unless and until you input something important, then only you will get the actual output, or else system will just keep on showing the results and you will be confused which is correct and which is wrong. So understanding the input, what are the inputs, conditions, and giving those inputs to my simulation system or software are the important thing to understand with the simulation part. Now, for any basic analysis, that simulation can be divided into three basic steps. Okay, so those steps are pre-processing, solution, and post-processing. Now, let us discuss these in detail. I will be focusing on these steps only for today's talk. So, the what do we understand by this? Pre-processing is about preparing part for the analysis. Solution is basically automatic. The software is having its algorithm. So whatever software you are using, ANSYS, HyperWorks, Nastran, LS Dyna. So all those softwares are having automatic solutions. So you just have to click on solve and they will perform their algorithm and solve the problem for you. So in solution part, we don't have any role actually. And in post processing, whatever you have solved, the results of that will be the post processing part, like displacement diagrams, your stress diagrams, okay, deformations in final deformation because of the force, pressure, or impact. Those all things can be represented in post processing. So there will be graphs, there will be numbers, there will be list of elements and nodes having, each node is having displacement, everything is there in post processing. So unless and until we do the pre processing part, you cannot proceed for the post processing. And most of the time post processing is again, a lot of commands will be provided, you just have to select which kind of commands are there you want in your solution. Okay, so this solution and post processing part is quite easy to perform, you don't have to do anything, but this pre processing part is plays very important role, that is basically the inputs which we provide for getting a solution. Okay, so this pre processing part is again divided into number of steps, we will discuss those steps. So this pre-processing stage starts with the input as a file transfer. Okay, so most of the CAE softwares don't have their CAD domain as a CAD software which they work on. So if you are this is like change of software. So if you are working on SolidWorks, we take the analysis in ANSYS. So you have to transfer that part from SolidWorks, which is a different user interface, to the ANSYS, which is again different user interface. So this transfer of interface will give you the problem. Okay, so that for that you need to have a standard file format. So step is one file format which can be used. IGS is again the oldest file format which can be used for such transfers from one software to other software for 3D. And most of the time there is no data loss in these softwares. The recent softwares which we have, those basically take directly input from the Creo or SolidWorks part file .plt or .sldprt. So those files directly taken in the recent software's versions. Okay, so no problem with that. The modifications or data loss is the second step by which we basically check whether there is a data loss is there or not. Now to explain data loss in very simple words, let us say my SolidWorks GUI is having some command like chamfer. Okay, it is giving a corner, a chamfer of 45 degree and 2 mm. But let us say my ANSYS GUI or any LS Dyna GUI is not having commands which is called chamfer, or command which will perform something like chamfer. So while transferring that file, those chamfers, fillets, maybe small holes, oil holes, which are there in your system or a product, that goes vanished. Okay, you will lose that data because my system or my GUI is not able to read those points. Okay, so that is what data loss is. So if there is any data loss, you need to modify those for the specific operation. So if your holes are not there, you have, if you lost holes, you have some commands in ANSYS or any CA software to generate holes at that instant itself. So you will generate holes in ANSYS, you will generate different fillets and chamfers in ANSYS, or remove different fillets and chamfers if not required, and then you proceed further for your analysis. So that is about the transferring from CAD to CAE or simulation. Okay, then there is a material properties part, and now material properties can be given to you as a given data. You can just input those data as a material properties, and you can proceed further with those material properties. Generally the material properties which are given are density, your yeah, so the densities will be given in general as a material property. Your young modulus will be given as a material property. So those properties you can give as an input to my system or problem, and those problem will be solved with those properties. The next is again very important. Two steps are very important. One is the meshing and one is the input conditions. That is maybe force, fixed supports, everything. So this mesh is again a very important point on which you can always focus on. So if you are having a coarse mesh in your system, the results will be wrong. If you are having very fine mesh, that is, mesh size will be very small, so that will give load on your system, and your system will not be capable of solving that mesh. So you can have different combination of mesh. You will not go for very coarse mesh, you cannot go for very fine mesh. So you need to find the best suitable point in between those two, which will give me the best results. And that comes from the experience. So you have to keep trying, trial and error for different projects or problems, and then you can think of the optimum solution for that mesh. The second thing which we can perform for meshing is you can concentrate on the specific area where that problem or that part is going to fail. Okay, so generally, if we are talking about fasteners, the fasteners on a plate, the part will fail at the holes. So what we basically do is we make a fine mesh around the hole, and we make coarse mesh around the plate. So there is no deformation around the plate, but there is large deformation around the holes. So we make fine meshes around the hole. So that is one example of specific area meshes. One more example I can give is if you have a cantilever beam and which is attached to the vertical plate like this, and if that attachment is perfectly perpendicular for a straight edge, there will be fine definitely that part is going to fail at the attachment of the cantilever beam. So for that, what you can do is you can add fillet there, you can add chamfers there, and then you can mesh that part with fine meshing, and you can check whether that part is going to fail, or we are doing any modifications that so that part is not going to fail in that region. So that is basically your mesh properties, and you can definitely try various methods of meshing. There are generally two or three shapes of mesh which are available. One is called triangular mesh, one is called quad mesh. Okay, for 2D and 3D, both the hex mesh and a triangular pyramid, those are the shapes which are generally available for meshing. The important point on meshing, again, we need to cover maximum possible area for meshing. Okay, and there are some specific softwares which give you the huge control on meshing, and people tend to use those softwares only for meshing. Okay, so we will be discussing those softwares in the end of this session. So that is the meshing part, very important. The meshing will decide what is the accuracy of answer you are getting from your system. Okay, so do focus on this meshing part, try to understand the methods of meshing, how you can go for coarse mesh, fine mesh, what are the different parameters by which you can uh, calculate the mesh length, each element's length, angle, everything. Those you can understand through the mesh part. And the last condition is again very important. For this last condition, you need to understand what kind of analysis you are performing. Okay, so if I'm applying load on a cantilever beam at the uh, one end, and one end is fixed, we need to understand which end is fixed. We need to make sure that displacement is zero at that end, and the other end is having a force which is going in downward direction. Okay, so similarly, if you have a problem, you need to understand the existing conditions and how we can perform those conditions on the software part. Okay, so what basically fixed support, force, pressure, what kind of components I can select that will perfectly reflect the conditions which are given in my problem. Okay, so for this, one more thing is very important. You can go for 1D or 2D analysis instead of 3D analysis in CAE to save time and your processing cost. Okay, so that is one of the options. So the example for that will be maybe a heat transfer through a wall. I can do that analysis in 3D definitely, but what I prefer to do is I take a cross section of that wall and make a temperature transfer, that is area, and I transfer one temperature, apply one temperature on one side, and other side I calculate the temperature heat transfer which is going from one side to other side. So in that case, replacing the 3D wall to a 2D surface, that basically saves much more time. It gives me the good quality meshing for area, and you get more accurate results compared to 3D. So if it is possible, if your part is uniform around the cross section, or if it is possible to convert that part into 1D model, like if it is a simple problem of cantilever beam, I will not model it in 3D, I will model it in 1D and try to solve it in 1D. So if it is possible, always we basically prefer to go for 1D and 2D, which gives me much more accurate result compared to 3D. So that is again one of the important thing which you can consider while selecting the method of analysis, 1D, 2D or 3D. So these are the basic steps of pre-processing. Once you give the correct data in pre-processing part, then you can move to the solution part. You can just do the solution part, the algorithm will do its task, and you will have a final value. Now in final values, that is post processing part, you need to clarify to a system that what kind of outputs you want. If you want displacement, then in which direction you want a displacement, x direction, y direction, z direction, combination of those, and what kind of pattern you want. You want a colorful image, color pattern on your model, you want a table pattern, you want a chart of the output, everything. Most of the things are available in the software, all the softwares which are providing CAE solutions, and those things we need to understand, and which part gives me the accurate result, those things you want to represent in terms of graph, maybe a model, maybe a table, everything. Okay, so that is the post processing part. And there is also a simulation, which is a video of applying, when you apply a force, how part is displacing. Those videos you can also store, you can show it to the to your faculties, you can show it to your client, so that you can uh, ensure that you have performed the analysis for that part. Now, this is the standard process which we want to understand. So that is a pre-processing, solution, and post-processing. Now let us talk about the softwares. Yes, so software which are available for analysis, you will find ANSYS everywhere, because that is the oldest software which are available to do these kind of analysis. But there are many other softwares or many other algorithms which are providing good solutions compared to ANSYS. So you can also try out those. Here again, like a CAD software, you can go with the domain. If I'm going for automobile industry, what kind of softwares my automobile industries do use for that simulation part, you can just check those online, and then you can select that specific software and learn those software step by step, what kind of analysis can be done in that software. So few of the softwares to name other than ANSYS, you have the NS Nastran, which is again a good platform for analysis and simulations. So the advantage of NS Nastran is it's a same GUI which is following for CAD, CAM and Nastran. Okay, so there is no data transfer from one part to other part. There is no data loss because of change of GUIs. So that is one advantage on which NS Nastran can be helpful. So that's why it is more popular. And there are some softwares which are like Hypermesh. Now most of people use Hypermesh only for meshing. They prefer to use for meshing. So Hypermesh is having the great control on the length of mesh, angle of mesh, finding errors in the mesh, manipulating those mesh as the user wants. So it is having a great control over each and every mesh and node points. So for that, you can definitely try Hypermesh. They have a software called HyperWorks, which basically does the simulation. So if you are interested, you can also go for those softwares with Hypermesh and HyperWorks. The same parts of Hypermesh can be imported in Nastran and ANSYS also. So some people prefer to do meshing in Hypermesh and solution in ANSYS or Nastran. So you can try those combinations of softwares if you want. Uh, so you select your software, which domain you want to go, in which domain those softwares are used, and then you can select a software. Same thing for certification. If you are going for a specific certification in CAE simulation, or you are performing any project, try to understand what kind of value that certificate is adding to your profile. Okay, and then what kind of contents are getting covered in that certification. So then only enroll for that course and or certification and get it clear with the certification. If you are a student, yes, certification adds a great value for your CV or profile. But again, I will remind you that if you are working for simulation or CAE, you need to understand what you are doing. Unless and until you understand, software will keep on giving you the results or solutions. You cannot predict which solution is correct, which solution is wrong, unless and until you fix your inputs and you understand those inputs correctly. Okay, so please do consider these things in simulations. To quickly revise what we have discussed, we discussed about CAD, the basics of CAD, selection of software, learning basics, projects and practice, and about the certification we talked about, how to select a software and everything. And later on, we talked about the CAE, that is simulation part, in which we understood the process which is used for general process which is used for analyzing any part, that is the pre-processing, solution and post-processing, in which most important thing is pre-processing. Okay, so please go through that process and understand each and everything for the simulation part. Okay, at the end, yes, I am happy that Planotech Media House has given me opportunity to come up here and share my experience with you all. If you have any queries, do feel free to contact me. I will be happy to solve your queries regarding design and simulation. Okay, so yeah, thank you for joining.
Hello, everybody. This is Professor Ravi Shekhar from the Mechanical Engineering Department at the Symbiosis Institute of Technology, Pune. Today, I'm going to very briefly talk to you about what are simulations and what is automation. So, let us get started. What is simulation? As you can see from this slide, and the presentation slides about simulations correspond with the book on titled Simulation with Arena. It's a very good book which talks about what are simulations, how they are applied, and especially how we can practice them with the software called Arena. So let's go ahead. Simulation. What is simulation? Simulation is basically imitating or mimicking real systems. So we see different kind of systems all around us, and if we want to imitate them or we want to mimic them and we want to control them, then we need to basically simulate them in an artificial environment. This is applied in many fields and industries. It's a very popular and powerful method. What are the different systems that we are talking about here? It could be any system. For example, any manufacturing facility or a bank or transportation, medical facilities, computers, freeways, businesses, legal systems, processing plants, restaurants, markets, theme parks, and emergency response systems. So these are just some of the systems listed out here to give you an idea about how the simulations can be applied in practically every field. You name a system, you can identify, and it can be simulated. So how do we work with the system? Why we want to have simulation? Because we want to study the system, we want to measure it, we want to improve it, we want to design new systems based on the existing ones, and then we also want to control it. Control means we want certain desired set point, desirable outcomes coming up from the system, and we want to limit or restrict the undesirable outcomes. So maybe we are just playing with the actual system, but instead of that, we can have a model or simulation of the system. So often it is impossible to do so in reality with the actual system. It is very difficult to, of course, you can measure the actual system, but it is very difficult to improve and design unless you know exactly what outcome has to come out. For example, if you want to understand how, once if there is a flooding in a river, then how is it going to affect the adjoining areas? We cannot wait for the actual flood. We would like to simulate it and understand the system and then try to take the preventive measures. So we have to make a model of the system. What is the model? A model is a set of assumptions and approximations about how the real system is working. So there is a real system, and based on that real system, we can have a model which kind of describes that system. And then we can study the model and manipulate the model instead of the real system, which is naturally easier, faster, and cheaper to do so, and also safer in many cases. We can also try different ideas with this. As I said, we can manipulate it, and we can make our mistakes on computer where they don't count, instead of doing it in the real world. And then we can, building the model itself is instructive, and we have so much to learn from, regardless of the results many times. And the validity of those models are also checked. How closely this model mimics or corresponds, or is how good this model is a reflection of the actual system. And that's why if the model is good, then we get almost same conclusions, in the broad sense at least, as we would get from a real system. What are the different kinds of models? We can have physical models, like material handling tabletop models that we see in schools and colleges, and then we have mock-ups. We can also have flight simulators, pretty popular. Then we can have mathematical models which represent the system mathematically, and then they can be controlled, and they can be controlled for automation, which will come to the point later on. So this is often represented by computer programs or mathematical models, and then we can manipulate these programs to try different things and try to get different results. Then we can also study the logical methods. So if the modeling is simple enough, we can use one of these things. But generally, the systems are very complex, and hardly a simple model will be able to fit. So, again, we cannot oversimplify the assumptions to make it simple. It gets simplified to such an extent that it does not represent the actual system anymore. So instead of that, we can have advanced modelings, analytical methods, advanced methods that will reflect the system better. So that's why we come to computer-based simulations. For example, numerical simulations and softwares which are specifically meant for simulating certain tasks. And then the real power of simulation will be visible when we can study and manipulate complex models for complex systems, which are more realistic. Now, this is a brief history of, from 1970s onwards, how simulation became more and more popular. In 1978, in a survey, it was ranked 5, but gradually in 1979, it was ranked 2, and then in 1980, it came up to rank 1, utility and interest, and then up to 93. All the statistical analysis and the simulation became more and more commonplace, and heavy use of simulation was reported. Now, the advantages of simulation. So, there are a lot of advantages of simulation. You can have the flexibility to model things as they are, and also I have listed down already a few of them mentioned, but most important of them is that we can handle uncertainties. A lot of complex systems have uncertainties, a lot of variables, a lot of parameters which are difficult to predict exactly what will happen in different scenarios, and we can't really have a control over the real systems to actually do it. Many times not safe also. But then if we have good models, then we can handle these uncertainties, and we won't have to face this danger of ignoring the system variability. And because of which we'll have better predictions and better response characteristics for different situations. For example, in the case of COVID. So the better models they are, the better fitting, the better predictability they have, the better we are suited to handle uncertainties. Advantages of simulation continued means there is one more advantage is that gradually over the years the computing power has been increasing as per the cost. So estimated that 75% of computing power is used for different types of simulations alone. And then there are dedicated machines and graphical user interfaces which help us have better and better simulations and processing. But then there are some limitations, friends. We always we can't expect exact answers from simulations because, as we noted, that there are some approximations and assumptions that go into the modeling. So what do we get? We get approximate answers, we get general directions, we get general indications, and many times they're also good enough. So, and this is true for many other modern methods like AI. And we can get random outputs from stochastic simulations, but we can there are a lot of things like noise control, replicability, sequential sampling, variance reduction, so that we can make our model better and we can have our answers which better explain the phenomenon. What are the different kinds of simulation that we can see? So basic classification: static versus dynamic on the basis of time. So if the time has a role, then it becomes more dynamic. And then what kind of a role the time has? It can be continuously variable or discretely variable. So if it changes in different ways, we can have different kinds of simulation. Then deterministic versus stochastic based on uncertainty. And therefore, because of uncertainty and rapid change of model system behavior based on time, in a lot of processes, these kind of models, discrete change, stochastic, dynamic, are more preferred. Okay, and then using the computers to simulate, we can use multiple languages like Fortran that were used long ago, and support packages like subroutines for list processing, bookkeeping, etc. And finally, spreadsheets came about. Then the next generation of simulation languages include GPSs, SLAM, and all. These are very popular and still in use. And this is the next point in the learning curve for advanced features. Nowadays, high-level simulators are being used with a very easy graphical interface, which help in easy simulations, easy to learn, and very quick to model the system and simulate them very fast. But then they are domain restricted in manufacturing and different communications, and they are very much specialized for the particular systems they are dealing with. Because using this presentation for this book, I'd like to speak about Arena also. So it's a good software for simulation, where different multiple levels of modeling can be done. Now, let us look at the evolution of simulations. The use of simulation has evolved over a period of time. Starting from 50s and 60s, if we see, the simulations were very expensive and specialized tools were used, required very big computers, basic languages were used, and the processing cost, if you look over here, up to $1,000 per hour was consumed. Nowadays, now in the next decade, our 70s to 80s, the computers got faster, cheaper, and the value of simulation was more widely recognized, and they were used up in situations like car plants, assembly line performance improvement, and things like that. In the next decade, it grew even more with better microcomputer power, similar software expanding into GUIs and animation, which will become more and more popular, and they also kind of cascaded into other areas apart from military and technological like manufacturing applications like services, healthcare, and other business processes, and different kinds of simulations emerged. So still mostly they were being used in large firms, but in the present they have started proliferating into smaller firms, into educational institutions, and basically they are becoming more and more standard. And even the future, and even now the simulations are having the features which provide the consumers with real-time control characteristics. So the future will be specialized templates, more and more specialized templates for industries, and automated design analysis. So even these processes of design analysis are going to be more and more automated. So that's all about simulations. It was very brief. I hope it was useful to you. Moving on to automation. These slides by David O'Sullivan. This is his website. www.owl.ie. Industrial automation basically deals with automation everything in manufacturing, whether it may be storage systems or handling systems or assembly lines or production lines. Uh, this automation is accomplished by using computers, controllers, and software. Controllers are also coupled with actuators and sensors. What happens is basically it's like a feedback control loop systems and different types of control loop architectures in which we want to have a desired output and we manipulate the inputs to get that output or to maintain that output. So the outputs are continuously monitored by the sensors, different types of sensors, and based on the desired set point, the error is calculated between the actual functioning as compared to the desired functioning, and based on that error computation, the controller decides upon, based upon a pre-programmed logic, the controller takes an action, gives a signal for the action to the actuators, which are like your piston cylinders or your motors and like that, which in turn affect the process in order to bring it back to the desired uh, output. So look at this picture, friends, how it looks like, a very, very complex control system. And then similar systems and automation in robotics in different industries like this assembly line or washing line. Then, then we have automated guided vehicles. We have material handling equipments. Then we have automation in manufacturing different machinery and so on. Then similarly, a different branch of automation is also into material identification technologies using different barcode scanners and readers. And these have also proliferated into our supermarkets. And then this is the example of exactly the example of a simulation of an actual model. So these are the softwares used for design and analysis, also a part of automation. So automation is a big group. So how did this all start? Why automation? Because see, the realities of the modern manufacturing include globalization, international and national, local outsourcing. So because of the products being outsourced and the products circling through different countries to get assembled based on the economies of scale, automation became more and more meaningful to implement. Then there is contract manufacturing. There is an increasing trend towards service and quality expectations increasing and increasing competition. Therefore, there is a need to improve the operational efficiency, and that's why automation is justifiable. After this brief introduction of the automation, let us go into how automation is actually implemented in different systems. So a production system, talking about industrial automation in specific, production system is made up of support systems and the facilities. Facilities means your factory equipment and the layout. And the support systems means everything to support that manufacturing. For example, design, analysis, manufacturing planning, capacity planning, production planning, and manufacturing control, inventory control, quality control, and the like. All these support functions are grouped around the system facilities to enable maximum productivity and efficiency. Now, automation enters both of these areas. It enters the factory and equipment by having automated machines, and it also enters all these business design, planning, and control functions. So we have computer-aided design, we have computer-aided manufacturing, we have computer-aided process planning and control, and so on. And when we integrate them together, it's called computer integrated manufacturing with proper information flow. And the next stage in Industry 4.0, I'm not going to explain today. It is also integrated with communication technologies and technologies like cloud computing and all. But more on that later, sometime later, not today. So let's talk about automated systems in our facilities. Okay, so these facilities, the different facilities, how the automation enters there. These are the examples. So automated machine tools, then transfer lines, assembly systems, industrial robots, which are replacing the human hands, robotic arms, and automated material handling and storage systems, and inspection. So we have machining, we have storage, we have handling, we have inspection. Everywhere automation has entered. Based on this, we can also categorize automation into three categories: fixed, flexible, and not programmable. On the y-axis, we can see variety, and on the x-axis, the product quantity. So when my product quantity is very high and the variety is quite low, I can go in for fixed automation. When my quantity is very less, but I can my automation, I want it to be suitable to create a lot of different kinds of varieties of products, like job shop type, then programmable automation is the right choice for us. And when I want to have something in between, flexible between both of these two ends, then I will have flexible automation. So fixed automation means suited to high production quantities, highly initial investment, because that investment is for custom engineered equipment for a particular product that I'm going to manufacture in very large quantities, very high production rates, um, thousands of them, and then but it is relatively inflexible in accommodating a variety, because it is not meant to. It is meant to produce at high rates, high volume production of a product which has a good demand, sustainable demand, lot of demand, and therefore this initial investment is high, but it is recovered quite quickly. In case of programmable automation, and this is at the other end of the spectrum, very low quality, I'm sorry, very low quantity but very high variety. In that case, what is justified is very high investment in programmable equipment, because it has to be very flexible to cater to very different products, and but the production rates are very low, and it is highly flexible to deal with variations. Somewhere in between these two is the flexible automation. Of course, here also high investment is there for custom engineer, but then this kind of automation is very suited for producing parts having very few variations in their design characteristics. So if we have parts having little design variations here and there, we call them variants, then this kind of flexible automation is the best suitable for us. Then the reasons for automating. What are the different reasons that we need to automate for? Of course, we can also talk about reasons for not automating, but today we'll talk about why to automate. So yes, I need to increase my labor productivity because I want to be more efficient, and per labor output can be improved by automating machines. This way, the cost will also come down, and I can also balance the effects of labor shortages by having automation in the right amount. We can also reduce and remove routine, manual, and clerical tasks. So all the routine, manual, and clerical tasks, including the physical tasks, are all going to be automated first. The fifth point is very nice. Worker safety. This should be far above. So the worker safety means that by automating, we can ensure much higher degree of safety for the workers in the industries. As we know that in first industrial revolution, things were not very safe for the workers, but now the factories are much safer thanks to automation. And similarly, we can have a product quality improvement, but also I will say here consistent product quality, reducing lead times, accomplish what cannot be done manually, of course, complex tasks. And the last point, which is not visible over here, is to avoid the high cost of not automating. This PPT, this slide is basically based on the book by Mr. Groover on I think computer integrated manufacturing and flexible manufacturing systems. So the high cost of not automating, how can we avoid that? Because if my competitor is automating and he's able to sell the goods and produce goods much cheaper, then in order to survive, it will get me very costly if I don't automate fast. To avoid that, I should automate. How to automate? Now, the automation principle basically is based on three fundamentals. One of the principles: understand the process, simplify it, and then automate it. We don't just jump to the automation step. We have to first understand the existing process. Otherwise, what will happen is we'll automate it, and then the automated solution will be far more complex for the end user as compared to what it was before. And it should be able to simplify the process and make life easy for the end customers rather than making it more difficult, as happens in some cases. And then what the strategies I can involve in my manufacturing. I can make my operations more specialized. I can combine different operations into one setup in one station. I can have simultaneous operations going on at one station. I can have different stations connected together, integrated together by automated material handling, more flexibility. I can have improved material handling by automated guided vehicles or automated storage and retrieval systems. I can have online inspection so that I don't have to inspect when the whole thing is done and the batch is rejected. I can start inspecting while it is being manufactured or assembled. And optimization, control, and integrated manufacturing. These are all the automation strategies. Okay, so this is one of the migration strategy I'll briefly go over. Look at this y and x axis over here. When the product demand is quite low, it is prudent to start with manual production. It's not, when the product demand is low, I should immediately go and automate. No, hold on. We should start with manual production. And this phase one block over here shows that there are manual workstations and manual material handling. So there are workers working on machines. It's not completely automated, and there are workers who are engaged in transferring the units between the two workstations. This figure is also from the same book by Groover. You can refer to it. Now, in the next stage, when the product demand increases, then this becomes the case for more automation. Beginning of the automation. Phase one, there was no automation at all. In phase two, we increased the automation by having these workstations automated completely and hardly any worker involvement. Only worker involvement remains is in material handling between these automated stations. In the next stage, phase three, when the product demand increases even more, and then total complete automation becomes highly justifiable, where we have automated machines connected by automated transfer lines. This is how we can gradually migrate towards automation, especially in developing countries. Now, what are the different automation elements? What are the different technologies and systems? We have control systems. We should also know about sensors and actuators, machine tools, robotics, logic controllers that are programmable, material handling and storage systems, identification systems, machine vision kind of things, and also barcode and identification, different technologies. Then grouping of different manufacturing cells and group technology, flexible manufacturing systems, and also layout of the different assembly lines and how to automate and have maximum operational efficiency. So that's it from my end. Thank you guys for your patience listening. I hope this was useful to all of you. And the automation story doesn't end over here, folks. This goes on to Industry 4, which is the next advanced topic that everyone is talking about, smart manufacturing and smart factories. That's it for today. Thank you very much. This is Professor Ravi Shekhar from Symbiosis Institute of Technology, signing off. Thanks a lot.